Hello, welcome back to Math 7 with Mr. Passon. Today we are starting a new unit. We're talking about area and shapes in the plane. And our first one is going to be, we're going to have a few lessons on circles. So today we are talking about the circumference of a circle. Now, first thing you need to know is what is a circle. And a circle is the collection of points in the plane that are all the same distance from some central point. Now, I'm going to try to draw that point in the middle, and I'm probably not going to do a great job. But my goal is to put a little point right there in the middle and say, hey, I want all the points that are the same distance from this point here in the middle. So if this is 1 meter away, this is 1 meter away, this is 1 meter away, this is 1 meter away. So the circle are the collection of points that are exactly the same distance from this central point. Okay, now, there's some important names to go with that, and in fact, that distance that we say from the center to the edge, to the points that actually make up the circle, that is called the radius. Alright, so, the radius tells you how big a circle is by measuring from the middle to the edge. Alright, and that point, that distance has got to be the same from all the directions that you go in this middle point. Now, if we were to cut the circle in half, going straight through it, so we have to go through that middle, that length from one side of the circle to the other side of the circle is called the diameter. Okay? And you'll notice then that the diameter is twice the radius. Then we would talk about if we moved around the circle. So if we went all the way around the circle, we'd ask maybe how far did we walk, or say we wrapped a piece of string around the circle and marked the two ends, and then stretched out or rolled out that string straight, and we ask how long is that string. That's going to be called the circumference. And we know other words that have that, because circum is a part that means around, so circumnavigate was when someone first sailed around the world. Alright. So that circ is actually the same circ that we get for circle, right? That actually means circle, and so we're looking at those three things. Now, we want to label the parts of that circle, which means we need to draw them. So I'm going to grab my line tool here. I'm going to start with my diameter, and I'm going to put that sort of here, going through the middle, right? Then I'm going to add another one going from my middle point out to the corner. So our first term we saw was the radius, right? Now I can actually probably make this smaller, move this over here, and I'm going to use some arrows. Alright, so let me grab my little arrow tool and say this is a radius. This is a diameter. And then the length to the outside, sort of my path around, that is going to give me my circumference. Okay, so we've got the radius, the diameter, which is all the way across, and the circumference. We have another one that we want to introduce. It's actually called a chord. And so this is an example. Oh, that's supposed to be a line tool. Let me switch that to a line. Delete. Select this. I'm going to change it to a line. Nope. We'll just select this one, delete it, make sure we're set on line tool, and this, like I said, is a chord. Now there's other interesting ones called secants and tangents and other shapes, but those are the ones that we are focused on, is the radius, the diameter, the circumference, and then a chord. Okay? Now, one of the things we're interested in is how these things are related. Now, the chord is a weird one. You could clearly draw a small chord and a long chord, but the radius seems to be connected to the size of the circle. The diameter is inherently connected to the size of the circle, and we want to ask, is it that in a fixed way? So what we're going to do is we're going to check. Now, the scenario that we set this up is Micah and his friends work at a tire factory, and they make tires of several different sizes for different vehicles. Fill out the table below to show how the diameter and circumference of the tires are related. So here we've got our toddler bike. The diameter of the tire is 14 inches. The circumference is 43.96 inches. If we do the ratio of the circumference over the diameter, that's that divided by that. I'm going to go ahead and grab a calculator, and mine comes out to 3.14. Let's check out our ratio for the next one. We've got 56.52 divided by 18, and again, that is 3.14. If we look at the next one, we've got 75.36 divided by 24, and that is 3.14. And then we've got 113.04 divided by 36, and that is 3.14. So what do we notice? It looks like there's a connection between these. The ratio is constant. So if we know how far it is across a circle, then we know how far it is around a circle, because they're connected by this number over here. Alright? Now, the circumference of a circle is the distance around the circle. It can be found using two formulas. We can either say the circumference C equals pi times d, and pi is that special ratio factor. Alright? Now, we can also introduce that character, so I'm going to do C equals times d, and I'm going to put in that character. So, if we look for the pi symbol, which it should be along here, where are my Greek letters? I am not seeing any of my Greek letters. Alright, I'm not going to worry about it for now then. So we're going to think of it as pi. Now, there is the symbol there, pi, but we could also do this in terms of the radius. Remember, the radius is only half the length of the diameter, because it goes from the middle out. So if we did pi times 2 times r, that would also get us that same distance around. This 2r, 2 times the radius, is the same length as the diameter. Alright? Now, in our class, we're going to always approximate pi with 3.14. It is actually, it goes on a lot longer, 3.1415926 something, and it just keeps going. But now we have to think about what piece of information is given. So here, we are given the, think about it, is this the radius here, or is this the diameter? This is the radius, so we should use this formula here. And we see pi, C equals pi times 2 times r. We plug in the values, well, so our C equals 3.14 times 2 times 6. If we wanted to measure it in terms of the number of pi's here, well, that would actually be 12 pi's. And if we figure out what 12 times pi is, I'm going to pull up a little calculator here. 37.68. Okay. Now for this one, we're not given the radius, we're given something that goes all the way across. That is the diameter. Okay. Okay. So this time we are given the diameter, so we're not going to use the radius formula, we're going to use the diameter here. And we say C equals pi times d. Okay, so our circumference equals 3.14, well, is approximately 3.14 times 14. So this is not exactly pi, it's just very close. So we could say their circumference is 14 pi, and we can figure out what that is. So we've got 14 times 3.14, and that is approximately 43.96. Now this one should be centimeters, and I forgot the units on this one. This one was inches. Lastly, this one is our, we have our radius again because it's our measure from the center out. So we're going to use this formula over here. Then we plug in our values, so C equals 3.14 times 2 times 3.5. If we look at the last two numbers, we'll say that's 7 times pi, so 7 pi. And if we figure out what that is, we got 21.98, and that is meters. Now I am going to make that text box just a little bit bigger, so that way that fits like that, and throw in another enter. So there we go. Cool. Now let's look at this situation here. We're going to try to use our vocabulary correctly. So a Ferris wheel, and here's our Ferris wheel, travels in a circular motion, so you go around and you go around sort of like this, and measures 40 meters from the top car to the bottom car. So if we draw that line in, I'm reconnecting, so I'm going to wait for this to reconnect. Okay, so let me draw a line here from our top one, from the top of the top one to the top of the bottom one, and you'll notice that that follows basically the diameter of our circle, right? So 40 meters from the top to the bottom, then the diameter, which is actually the second question here, the diameter is 40 meters. The radius, well, the radius is from the center to the out, so it looks like it's half the diameter. So that should be 20 meters. Now, if you were in the car and you traveled around, that's as if you traveled on the outside of the circle. So we have to ask, what happens if we travel that, how far will we go? So we're going to take our pi times, so we want to find our circumference, and that's going to be our pi times d. Alright, so we're going to do 3.14 times the diameter, which is 40, and we get our circumference is 125.6 meters. Now this one, let's read this one. Another Ferris wheel, a car will be traveling at 100.48. On another Ferris wheel, a car will travel 100.48 meters to go once around the wheel. That means we're going around the wheel. That is our circumference. And we want to know what is the height from the top car to the bottom car. So we're looking for the diameter. So we use our formula, C equals pi times d, but in this case, and again it's reconnecting, so I'll pause here. So C equals pi times d, but in this case we know the C equals, 100.48 meters, and the d is the thing that we're trying to find. So we set up our equation, and we want to solve for d. Okay? Well, here, how do we get rid of a multiplication? We know we divide both sides by 3.14. So here we've got 100.48 divided by 3.14, and we get that our diameter equals 32 meters. So this is a little bit smaller of a wheel, whereas this one was 40 meters from top to bottom. This one's 32 meters from top to bottom. Go ahead and summarize what you learned today, and we will continue on with the next one.